I've always had an interest in how research can offer new options to our patients that weren't available previously. In addition to clinical training as a vascular surgeon, I've also had formal training as a translational scientist. I find it rewarding to investigate new ways to treat our patients and to help them walk further, live longer, and potentially even have less surgical procedures.
Brian is one of those rare surgeon scientists that has the energy, the training, and the desire to make a scientific impact and to embark on a scientific career.
What I like about research is the ability to identify a clinical problem, to come back to the laboratory setting and to work on a solution. And it's the process of finding a new way that hasn't been described before, and being able to bring that back potentially to the patient to help them lead a better quality of life that I find exciting.
The significance of what Brian is working on is that vascular bypass patients, the graft that they are fitted with in terms of the vascular surgery often will fail. And it's these failure mechanisms that many of us are trying to address and to solve. So Brian's research, if successful, will alleviate the problems that come with vascular bypass failure. And this is bypass of diseased arteries, specifically in the legs, but also in the heart, but also the grafts that are used or implanted as access sites for patients with dialysis. So there's many patients that undergo dialysis every day, and the grafts that are used for these patients will fail. So this has really the potential to help millions and millions of patients.
Vascular progenitor cells are a cell type from the bone marrow that circulate in the bloodstream. Evidence suggests that after a vascular bypass, these cells may actually form an aggressive healing response at the site of the surgery. This may lead to graft narrowing and ultimately failure of the vascular bypass graft. We believe that if we deplete these cells temporarily at the time of surgery, we may be able to prevent graft failure, and this may lead to better outcomes for patients after a vascular bypass graft.
University of Pittsburgh is a special place that offers a rich training environment for young faculty such as Brian that have novel ideas. There is a rich history here between the medical center and the university in bringing biomedical science techniques and ideas and novel therapies to the clinic or to the patient to help patients very quickly. So having the support network that is existing here with the science, the scientists, the medical school, the engineering school, the bioengineering department, and many other resources will enable young faculty such as Brian to succeed more quickly than in other places, I believe.
The Wylie Award has traditionally helped a lot of our young vascular surgery researchers in the United States develop into independent researchers in the future. And I believe the Wylie Award will do the same to Dr. Tillman in promoting his career and allowing him to become independent researcher.
In 10 years, I see myself continuing to address problems that face patients with peripheral vascular disease, and hopefully being able to implement some of these new therapies to our patients. It's my hope that this line of research will give us new options to help our patients lead better lives.